Hello everyone, thank you so much for joining us today. My name is Lauren Tran. I am a partner solutions architect specializing in AI and ML, and today I will be covering prompt flow. I will walk through an overview of what prompt flow is, how you can interact with it. We'll go through some capabilities of the tooling, and we'll also walk through some basic foundational concepts and different components that you're going to need to be able to build your flows. And finally, I will also walk through some demos, both in Azure Machine Learning as well as VS Code, so that we can take a look at a few very common scenarios that come up over and over again with partners and customers. To begin, what is prompt flow? At a high level, this is tooling that Microsoft has developed to help you basically streamline the end-to-end development of your LLM applications. So this is a very comprehensive suite. It's a solution with many different features. We will walk through the different capabilities today. One of the nice things about prompt flow is you can see on the right-hand side of the screen, it allows us to use a visual graph to easily connect our different components within an LLM application. So that's going to be our prompts, it's going to be our calls to our LLMs, as well as any Python code that we have to orchestrate that logic. And one of the most powerful features that I love about prompt flow, I see lots of different partners using it, is the ability to do prompt tuning and prompt engineering very easily using prompt variants. So I will showcase that later today in a demo. But in essence, with variants, we're able to try out different prompts and test them against our LLM to see how the different responses evaluate. And with this, now we don't have to use the manual process of inputting different prompts, sending them to the LLM, documenting the responses, and testing different versions manually. We can now do bulk testing against our different variants to see how effective they are. After we do our testing, we can deploy and monitor our flows. So when we're happy with the flow, we can deploy with a simple one-click deployment so that we have our real-time inference endpoint, and in production, we can actually monitor the metrics that we use for evaluation. Let's take a look at the end-to-end lifecycle a little more in depth that we talked about on the previous slide and see where prompt flow can help. In those early stages of design and development, we need to be able to design our logic, our prompts, and our LLM calls. So this is where that visual graph that we saw comes into play, and it lets us easily build and modify our control logic. And once we've built and debugged our flows and we're satisfied with testing on a small amount of data, we can move on to the next stage of the process. In the evaluation and refinement stage in the middle of the screen, we want to be able to evaluate with large-scale testing. And that's where prompt flow has this really nice feature that we can upload bulk data and we can test our application with those large data sets to see how we're performing against different metrics. And these metrics can be built in or they can be custom, but ultimately they allow us to measure the quality, relevance, and safety of those generated responses. And then finally, once we're satisfied with our building, our testing, then we're ready to productionize. That's where we'll use prompt flow to deploy our flows as real-time endpoints for inferencing. And then we can test those endpoints with sample data. And in production, we can monitor our performance against those key evaluation metrics. There are multiple ways to use prompt flow, as shown in this slide. So we can leverage the cloud UI via either Azure Machine Learning or the Azure AI Studio. I will demo this capability. And we can also develop locally, if we'd like, using the VS Code extension and the Azure Prompt Flow SDK and CLI. First, we're going to take a look at the Azure Machine Learning Prompt Flow Cloud UI. But before we jump into that, let's go through a few foundational concepts regarding prompt flow. The following slides have screenshots from the AML UI as a visual reference for you. We've been talking about building flows. So first up, what is a flow? Flows are executable workflows that you can run, and they are composed of smaller nodes. So each node handles a specific task in your workflow. You can think of them as smaller functions within that broader application, and you can see each node on the right-hand side of the screen. Each of them do different things, and you can connect nodes into a complete flow, as shown as well. So a flow essentially just guides data through your application. It comes in as an input, and then it gets manipulated with the different nodes, and finally comes out of the flow as the return value. Ultimately, you're going to deploy this flow as an endpoint, so it will be the API response that gets returned. There are 3 different types of flows. So standard flows are for general applications. You've got chat flows for conversational applications, and then evaluation flows. Those flows let us test our flow with bulk data so that we can measure different performance metrics. Next up, we have tools as a concept. So tools form the building blocks of our flows, and each node that you saw on the last slide is created with a tool. You can think of tools as a simple unit within your flow that executes a specific function. There are lots of different types of tools, but the most common ones are LLM, Python, and prompt tools. We'll go through each of these in our demos. The LLM tool allows you to easily call an LLM, pretty basic. The Python tool lets you either write your own Python code or lets you bring over code from your existing application. And here's where I'll call out a very common request. You can use LangChain within your Python tool, so it lets you easily integrate with your existing LangChain code. The prompt tool lets us compare different prompts and lets us easily prepare and experiment with prompts using Jinja templating. Like I said before, there are lots of other tools as well that we can leverage. Some of them are listed here, but the list is actually more extensive than this. We've discussed flows and tools so far. Both of those have inputs and outputs. So your entire flow as a whole has a set of inputs and outputs, and then each tool within your flow has its own inputs and outputs. So at the flow level, the inputs are basically your data passed into the flow as a whole. This could be a user question, for example. If it's a chat flow, it could be the chat history. And then you've got outputs that are data produced by the whole flow and then ultimately returned as your API response to that deployed endpoint. At the tool level, we also have inputs and outputs. So a tool input comes from either the user at the beginning of your flow or from the previous node, and then data gets processed by the tool and returned as an output. Now we're ready to go ahead and jump into the Azure Machine Learning Cloud UI. So first up, we'll go through a very common pattern and build out a RAG scenario. The first thing we want to do is navigate to the Azure Machine Learning Studio. That's at ml.azure.com. And as soon as we're there, we'll see this landing page where we can create a new workspace. That's where we'll be able to create our flows. So we can go ahead and enter a new workspace name. And I will create a new resource group for this webinar. So I'll call this AI Unlocked RG. That's a logical grouping for my resources. And I can use East US 2 as my region. So let's go ahead and hit create. And while that's creating, we can go over to our Azure portal, and that's at portal.azure.com, to create an Azure OpenAI resource. And we will need this to be able to leverage Azure OpenAI within our flow. So I will also select the new resource group that I just created. For consistency, let's choose East US 2. And I'll go ahead and name this. For the pricing tier, we'll select standard, hit next. Click through, validate, and create. And while that's creating, we will also go ahead and create a search service, which we'll need for our RAG deployment. So under resource group again, the same resource group, AI unlocked search, east US 2, review and create, and go ahead and create that. So our resource has created. Let's go ahead and switch back over to our Azure OpenAI Studio. We can select that new resource that we've created. And within this resource, we can take a look at the models that are available to us in this specific region. We can deploy GPT-3.5 Turbo, GPT-4, and also a text embedding model. So let's go ahead and create our GPT-4 model. So we can hit deploy. We'll hit create. Let's go ahead and also create an embedding model so that we can embed our user query as vectors in our knowledge base. So let's hit deploy. Again, I'll use the same name. And now under deployments, we'll see those two models. So by this point, our Azure Machine Learning Studio workspace has been created. We can go ahead and click into that. And there are lots of different features available in the ML Studio. Today we'll be focusing on prompt flow. So we can go ahead and click on prompt flow. And within our prompt flow tab, there are a few different subtabs that we have here. So within flows, this is where we create and author our flows. First, before we create a new flow, let's go over to connections. This is where we're going to want to create our connection over to our Azure OpenAI resource that we just created. And this will allow us to use those model deployments. Here I can select my subscription as well as my resource that I created, and we can go ahead and link to our model with the key and the base URL. I'll enter those values in and hit save. The other thing that I'll want to do is go ahead and create my vector index. So under vector index, this is where I will actually create that knowledge base that we'll use for our flow. So let's go ahead and give this a name. And I've got some data that I want to upload from my local folder. So I'll click the upload button, and as you can see, I've got a few documents here that are brochures for a travel agency. There's different locations and some general company info. And we will use that to populate our index. So if we go into the folder, or at the high level, we can upload the entire folder. I'll hit upload, and then I would like to use Azure AI Search as our vector store. And I can also create a connection over to that Azure AI Search or search service that we just created. Similarly, let's go ahead and enter the API key and the base URL, and you can find those from your Azure portal. Okay, we'll hit save and click through this wizard. This is our connection to our Azure OpenAI resource. Hit next. We'll want to create a serverless compute for running this specific indexing job. So let's hit create on just a standard compute SKU. And this will take just a moment to create. So our job details have populated here, and we can see the status of this job is running. What this is doing is indexing the data that we have uploaded here. So it is going through and chunking this data, embedding the chunks with our embeddings model, and then indexing the data into our search index. This will take just a moment to run, and then we'll be able to see our vector index. While our job is running, let's go back to our prompt flow tab and we can go ahead and create a new flow. So we'll hit the create button, and within this tab you'll see that there are 3 different flows we can create as we talked through in the deck. The standard flow, chat flow, or evaluation flow, we can create these from scratch, or we can also take a look at the gallery. So there are examples that are already populated that we can go ahead and clone to get started more quickly. In this scenario, we want to do RAG on our own data. So this is going to be QA on your own data, and we'll go ahead and clone this example. We'll enter a name, hit clone, and we'll be able to see this example. So up at the top, we've got inputs and outputs. And the input value is the question. So it's pre-populated with how to use SDK v2. We can actually update this with a question that is more relevant to us. So based on our data that we saw uploaded and that is currently indexing, we can say, what is Margie's travels? Now the input comes in the graph on the right hand side here. Now we see our different nodes, which are basically just tools. And the output comes from the final node here, answer the question with context. And as an output, we define that in the output value here. The answer the question with context dot output. Now walking through this flow, the first tool that we have is the embedding tool. And this is going to allow us to use our embedding model to embed the user question. So let's go ahead and fill out the value here. We created a connection already, the AI unlocked OAI connection, and we want to select the text embedding model as our deployment name. Moving along, for the next tool, we've got the vector index lookup tool. What this does is connects to our vector index that we're currently in the process of creating. And right now, the default value is just a sample value. And we're going to want to replace this with the vector index value that we created. So we'll be able to get that string in a moment. Next, we've got a Python tool. And this is where you can input your own code. So as you can see, we've got Python code here. This code basically retrieves our documents and creates our source context to be able to send to the LLM. Now, the next tool is a prompt tool. So with Jinja templating, we're able to pass in the context that we just created as well as the input question. And here we're specifying where these values are coming from. You can see them in the diagram as well. And finally, we are passing that to a final LLM tool. And this connects to, we can actually select the connection, our Azure OpenAI connection that we created previously. And we want to use the chat API with the GPT-4 deployment that we created. And I would like to respond with a text response. Let's go ahead and start a runtime. So that's actually the first thing we should do is create a runtime that we can run this flow with. And this will just take a moment to start the runtime. Let's go ahead and hit save, and then we will check back with our vector indexes to see what the status is. We can see that our AI unlocked vector index has been created. Now, if you were to run this indexing job more than once, you'll see that the version number will get incremented, and this allows you to choose different versions later on down the road. Over on the left-hand side, under Assets, we can click on Data, and we'll see this index show up. And if we go under the data sources details, then this is the URI that we will want to substitute for that sample URI. Let's go back to our flow. We copied that URI, and this the vector index lookup tool is where we'll want to enter that. So instead of the sample, let's enter the copied path. There's one final feature that we'll want to take a look at before we run this flow. So if we scroll down to our prompt tool, you can see that we have the ability to create different variants, and right now there's only one variant. But if I were to hit generate variants, then the system will actually create variants for me. So let's up this number to 3, and we'll connect to our Azure OpenAI connection. We can select GPT-4 and hit submit. Now, new variants are being automatically generated with our connection over to GPT-4. And if we take a look at these variants, you'll see they are slightly different than the default variant that we took a look at, but they're a similar description. So they're just slightly different ways of wording, and you'll see that oftentimes your wording within your prompts will make a large difference. So that's variant 1. We can take a look here. Again, a slightly different way of wording it, and the third variant as well. So now we can go ahead and run this flow. We have the option to select which node to run variants on. So I am selecting to run all 4 variants on the prompt variants node. We'll hit submit here. While this is running, I want to highlight another capability within the Azure Machine Learning Studio, and that's the model catalog. So within our flow, we've got Azure OpenAI running, but I also want to take a look at what's in the model catalog, because we may want to bring in a different open source model as well to test that as a variant. So under the model catalog, we see lots of different models. There's the Azure OpenAI language models, as well as different open source models. And specifically for this demo, let's look at the Llama 2 APIs. So I'd like to deploy one of the Llama 2 models, so we can go ahead and create, for example, the 70 billion parameter model. And if I hit deploy and create a real-time endpoint, I'll skip the Azure Content Safety for now, but in practice you will want to use it. Hit the acknowledgement. This is going to leverage a GPU machine to host this endpoint. Endpoint name, we'll call this AI Unlocked Llama Endpoint. Deployment name, Llama 2 70 billion chat 15, and hit deploy. Now this endpoint is in the process of getting created. While this provisions, we'll go back over to our flow and check on the status. So now that we've gone back over, we can see that all of the different nodes within our flow have our green check mark and they say completed. So if we take a look at the outputs now and the generated output, we can see that based on the context provided, the model generated a response that describes what Margie's travels is. So we were able to successfully chat with our data. If we dive a little deeper into how the LLM generated this response, let's scroll up to prior to actually making that final LLM call. And we want to go back up to where we did the retrieval logic. So this is our Python tool. And this is where we're searching through the vector index to get the right documents. And if we take a look at the output here, then we'll see that there are a couple of pieces of content. So we were able to retrieve the Margie's Travel Company info with some data as well as the source URL. And we also are gathering some data from the Las Vegas brochure, and we're citing the source there as well. So from that Python tool, we're outputting the context as well to provide to the prompt. We're creating the full prompt by stringing together the context and the input user question, and then finally asking the LLM. So that's where we get our final generated response that provides a grounded answer for us. Now I'd like to explore the evaluate feature. But before we do that, let's go back to our slide deck and look at some evaluation metrics. Within PromptFlow, there are multiple different built-in evaluation metrics that we can leverage. 3 of the most common ones I've listed here on the screen. They are groundedness, relevance, and coherence. There are lots of others, and we can also build our own custom metrics. Groundedness allows us to measure, well, how grounded our responses are based on the context provided. So even if the LLM generates a true response and doesn't hallucinate, the response could get a low groundedness score if it can't be verified against the source context. Relevance measures how relevant the answer is to the question. So again, the response could be true, but score low on relevance if it does not address the question. And finally, coherence measures the quality of the response as a whole and if it flows together naturally. I want to call out something pretty important, which is that we do not need to generate a ground truth data set for any of these metrics shown here. That tends to be a pretty big blocker for evaluating performance in these applications because it is a very time-consuming and complex process. For groundedness and relevance, we actually only need the question, the predicted answer, and the provided context. And for coherence, we only need the questions and the predicted answers. As we saw in the previous slide, we need to create a data set to be able to run our evaluation. So the initial data set that we'll need will just consist of questions. With the questions uploaded, we'll be able to run our flow and generate the answers as well as the necessary context to provide for the evaluation. So one of the things that we can create here is an output. And let's generate our context as an additional output. And I would like to select generate prompt context.output. I've already generated a file that we can get started with. So let's go ahead and click the evaluate button. And I've got a run display name here. Let's hit next. I have already uploaded a data file. So this was a CSV file, and you can see a preview of this data to understand what it looks like and the format that you'll need. So I've just got a header that says question. Right now, it includes 10 questions. We're previewing the top 5. These are questions that I want to ask as inputs into my flow, and then we'll go ahead and hit next. These are some evaluation metrics I can choose that are built in, but for now, I actually don't want to select an evaluation because first, in order to run an evaluation, I need to generate some predicted answers from the LLM, and then I also want to generate the context. So as we went through in the slide, we need the questions, the answers, and the context to be able to handle some of these evaluations. So let's go ahead and hit next. And we can submit. Now we can take a look at our runs list. And this will show our evaluation run that we just created. So you'll see the Q&A on your own data eval. There are 4 different evaluations running because of the multiple prompt variants that I have. Let's give these runs a moment to complete and we can check back shortly. Going back to our runs, we can see that all of our runs have completed for groundedness evaluation, and there were 4 different ones created for the different prompt variants that we have. So clicking on the first one here and going over to view outputs, we can see the input question as well as the context from our knowledge base, the answer, and the groundedness score. So this metric is evaluating the answer against the context. How grounded is this answer? We've got several 5s here. 5 is the best score. It goes from 1 through 5. We have a score of 3 here. The question was, is Shanghai a location that Margie's Travels can help book? We've got the company brochures within the content. And because Shanghai is never mentioned, the answer does say the context provided does not mention Shanghai as a location. It provides some other information, but ultimately it provides a score of 3. We've got a few more 5s, and then if we look over at the overall metrics, we can see our GPT groundedness score, that's 4.78, as well as the groundedness percentage. And going back to our run list, let's take a look at the second one. So if we look at outputs again, we can see in the overview tab, this comes from variant number 2. We similarly see the outputs here, the groundedness scores, some variation in them, and all up metrics 4.4 and 70%. So this does a little bit worse than the first variant that we took a look at. So when we have our evaluations, we're able to compare the different variants and their groundedness scores, and we can do this with other metrics as well, such as relevance, coherence, etc. For the final component of this demo, if you recall, a little bit earlier we created an endpoint from the model catalog, and we actually deployed our open source Llama 2 model. If we click into this endpoint, we can see that it has successfully provisioned, and if we go over to consume, we'll get some consumption info to call our endpoint. Back in prompt flow, let's create a new connection. So we'll create a custom connection this time and name it our Llama 2 connection. And using that consumption info we saw just a moment ago, we'll use endpoint URL and put in the value, and we will also enter the model family. That's Llama. And finally, a secret key for our API key. And we'll save that. Now that we've created that connection, we can go back into our flow, and we're going to add one final tool. We will add a open model LLM tool, and let's use the same name as our other LLM tool, but we will prefix this one with Llama 2 and hit add. Now we'll choose the chat API. We'll select default, our connection that we just created, and let's scroll up to grab this prompt message that we can modify for the Llama 2 chat endpoint. Let's provide the context as well as the question. We'll validate and parse our input. For context, we want to include the generate prompt context output. For the question, this is the input question. And we will go ahead and run this flow. And now that our run has completed, we can click on View Outputs, and we can see for each of the different prompt variants the Llama 2 output, as well as the output from Azure OpenAI GPT-4. If we wanted to do a bulk evaluation, we could do that similar to how we did before. We won't do that in the interest of time, but you can try that on your own. And that concludes our RAG demo. Our last demo of today's session, let's move over to VS Code. I'll show you local development and we'll look at function calling within prompt flow. We've opened up VS Code, and the first thing we want to do is download the prompt flow extension. So we will search for it over in extensions. And I've already got this downloaded, but go ahead and install the prompt flow for VS Code extension on your device. Once you have that downloaded, what we'll need to do is create a Conda environment, and I'm naming it prompt flow in my case, and creating an environment using Python 3.9. Now once this creates, we'll go ahead and switch over to that new environment. And we have a couple of pip dependencies to install. So we'll install prompt flow and prompt flow tools. Let those install, and we'll give this just a moment here. I'm going to check the prompt flow version just to make sure I've got it installed correctly. And then we'll open a new folder so we can create our flow. So I clicked on the prompt flow icon down at the bottom left. And within this, I just want to make sure I've got the right environment. I'll select click new empty flow and name that flow function calling. If I go over to the YAML, I can choose the visual editor and start creating my inputs. So first I'll do chat history. That's a list. We start with an empty list and we'll select chat history. Then we'll put in question. Leave that empty for now, but that's the user input. And then we'll start adding our tools. So first we want to create an LLM tool. I'm going to use this to call our GPT-4 model. Let's add in our connections here. We'll use the chat API, select our deployment. We can enter in some parameters and select our inputs for chat history and question. Next, let's take a look at our Jinja template for our prompt. First, we define the system message, then we include all of the messages in our chat history, and then add the user question. Now back over to our visual graph, we can open up the function calling section, and we can add auto for function call. These are our parameters. And to edit the functions, I've gone ahead and pasted in a function I've created and defined. It's get current weather, and formatted it. You'll see how we use the get current weather function in a moment. So next we'll want to add our own Python function in here. We'll add our custom Python code with the Python tool. In the runfunction.py file, this is where I can modify and bring in my imports, add my function code. So here's my get weather code. And then I'll also modify my tool. In this if block, we're handling the case where no function is called. And in the case that we do actually want to call a function, we'll go ahead and parse our arguments, pass those to the function, and make our call. We additionally want to capture a messages variable where we are storing the user question as well as the response message from the function. Then we're going to pass messages as our return value. So going back over to our diagram, we can select the response message value. That's going to be the SLLM output, and then the question is the user input question. The next thing we want to do is add a new LLM. This is going to handle our second response. So we'll choose GPT-4. What we want to do in this scenario is we've gotten the messages from the run function. We've determined whether we need to call a function or not. And for the response, in the second response, we actually want to just pass in the messages we've collected from the last block. And we will ask the LLM to respond to the user query. So let's substitute what we have in the template. We'll just put in messages that we constructed last time. We'll make sure we have the right input configured here for messages. And then we can do a little bit of testing on our flow. So if we run in standard mode, we'll actually run what is in the question value. So hello, how are you? The AI responds. Let's actually replace that with a question about the weather to see if a function gets called. And our function does get called. I want to show you the ability to create a breakpoint as well. So if we go into our run function, we can go ahead and set a breakpoint on the left-hand side. And let's go back to our diagram and we'll debug. And we can see that our breakpoint gets hit. Over on the left, I can expand this a little bit more. Take a look at my function call and we can see the location was captured as well as the get current weather. Now running another interactive mode test here. I can interact via the command line. Hello, how are you? The AI will not ask the function, but just responds to me. And then if I ask a weather-related question, then we do make a function call and return the temperature in Paris. My third user input does not require a function call, so I get back a pretty generic response. So we have successfully created a flow with function calling using GPT-4. I also want to show you one more test here. And what we'll do is we will go ahead and click on run again. We'll do this in standard mode so you can see some of the outputs. So running the question again about what's the weather in San Francisco, and we'll see that up at the top. We can scroll down and look at the outputs for each of our nodes here, and also the inputs. So if we take a look at run function, we'll see that we're passed what's the weather in SF, but we also see the messages that we've created from our run function, the return value. And this is a collection of the user question as well as the function response and the function that was called. You can see that over in our run function.py file. Now scrolling down, in our second call over to the LLM, we can also take a look at the inputs there, and you'll see those messages that came from the previous node, where we've got the function call, the name of the function that we wanted to call, and then the output, which is the current temperature in San Francisco is 72 degrees. That concludes today's session on prompt flow. Again, thank you so much for joining us today. Please look out for additional AI Unlocked sessions in the coming weeks.